So for Unit 2, I want to bring us back to electronegativity because we're going to be talking about ionic versus covalent bonding. And the difference between those has to do with differences in electronegativities. So this is a periodic table of electronegativities. And so if there are differences in electronegativities, then the atoms in a chemical bond do not share their electrons equally. So we're going to look first off, chemical bonds, as we start talking about how they share their electrons, are molecular interactions that cause a group of atoms to behave as a unit. And you have several different types. You have ionic bonding, which is between a metal and a nonmetal, where electrons are transferred because they don't share equally. If we look back on the previous slide, nonmetals are very electronegative. Metals have low first ionization energies, meaning they are easily able to lose some electrons. So the metals will lose the electrons, the nonmetals gain the electrons, then the oppositely charged ions stick together. And so that strong attraction, that electrostatic attraction that's explained by Coulomb's law, that's what the ionic bond actually is. Now, covalent bonding occurs when two atoms in a specific molecule share their electrons, but they're only sharing them between two different atoms. So, for instance, in a water molecule, there's two hydrogens and an oxygen. Well, there is a sharing of electrons between oxygen and one hydrogen, and then between the oxygen and another hydrogen, but they're sharing different electrons. So they've got their own unique set of electrons that they're sharing. And then there is metallic bonding, which is characterized by the delocalization of valence electrons in the metals, where they basically just let their electrons flow freely amongst the metal. And keep in mind, they can do that because metals have low ionization energies. But we're going to focus a good bit of our effort on chemical bonds. So the covalent bond is sharing pairs of electrons, and the degree of sharing depends on their electronegativities. And each covalent bond has a certain amount of energy associated with it called bond energy or bond dissociation energy, which is how much energy you would have to apply to the molecule to break the bond. Energy is required to break bonds because when a bond forms, energy is released. So to break the bond, you have to put energy into it. That may seem counterintuitive, but that's the way it is. If it released energy for bonds to break, then every chemical bond would just fall apart because everything wants to move to low energy states. So it requires energy to break bonds. And then bond length is the distance between the atoms' nuclei where attractive and repulsive forces are balanced. And so I've got a little graphic to show you on the next screen here. So if you take two hydrogen atoms, when they are sufficiently far apart, there's no interaction. As they move closer together, the nucleus of one is attracted to the electron cloud of the other, and vice versa. And then they begin to interact with each other as they form that molecule. But you can't push them closer together because if you try to push them too close together, then the nuclei will repel each other and you'll be overlapping their electron clouds too much. And so the bond length is the distance where these attractive and repulsive forces are minimized. So they're attracted to each other because the nucleus of one is attracted to the electron cloud of the other, but they're not too attracted to each other. So this is the minimum, this is the bond length of that because that's where you minimize those forces, and it releases 458 kilojoules per mole of hydrogen molecules. And we'll talk more about bond dissociation and all that good stuff as well a little later on. But one thing about where I talked about the degree of sharing, if covalent bonds, if they share equally, then the molecule is considered to be nonpolar. But if there are some differences in electronegativities, and let's go back and look at this chart. So, for instance, if there are differences in electronegativities, like between, say, nitrogen or oxygen or fluorine and chlorine, then they share unequally. And so the one that's more electronegative will pull the electrons more towards itself, giving it a somewhat negative charge, making what we call a polar bond. And then if it's really electronegative, it just pulls the electrons all to itself, and we say the electrons are transferred. That's when we become the ionic bond between the metals and the nonmetals generally. But every chemical bond between a metal and a nonmetal, or pretty much every chemical bond, has some covalent character and some ionic character. And so there's this broad spectrum. It's not clearly defined. This is ionic, that's covalent. So there's some ionic and some covalent character to just about every chemical bond, unless it's one where they're have identical electronegativities, like a carbon sulfur bond. They can form a completely non-polar molecule because they have identical electronegativities. Or, for instance, the O2 molecule, where it's two oxygens, where their electronegativities are identical. But if there's any difference in electronegativities, there will be some ionic character or some polarization of that bond.